problem a couple days ago, but it looks like it never went through, so I'm going to try it one more time. I'm interpreting the posted problem, which is this, as evaluation of this definite integral. In other words, these are the limits of integration right here, 0 to 3/4. So when you see a square root symbol like this, where we've got some perfect squares especially, you might want to use trigonometric substitution. So I like to draw a little right triangle. Since this has a minus sign, that means this 9 is the square of the hypotenuse. And when you use trig substitution, I try to remember SST. I want to use either sine, secant, or tangent. And I want the function that I use to have just the x in the numerator of the result, and I don't want the radical. So I put the leg here. Square root of 16x squared is 4x. And so I can see that the sine of theta is 4x over 3. And that leads me to everything I need to know to use the trig substitution. I'll let you go through all of this right here. Down here in red, I've circled something. That when x equals 0, theta equals 0. When x equals 3/4, theta equals pi over 2, because that's the inverse sine of 1. But one way to evaluate this is to find the indefinite integral, or the antiderivative of this, and then evaluate from 0 to 3/4, which is what I've done. So x squared is replaced with 9/16 sine squared theta. Dx is replaced with 3/4 cosine theta, d theta. And the square root symbol is replaced with 3 cosine theta. I dropped the absolute value symbol. These cancel out, and we get 9/64 is antiderivative of sine squared theta d theta. So this can be replaced with this. You can Google how to find the antiderivative of sine squared. It has to do with the fact that cosine of 2x is equal to 1 minus sine squared x. You can solve for sine squared x and easily evaluate this like I did here. If I distribute the 9/64, replace sine of 2 theta with 2 sine theta cosine theta, you see that theta is the inverse sine of 4/3 x. And how do I get sine theta cosine theta? Well, look back at the little right triangle. Sine of theta is 4x over 3. Cosine of theta is the radical over 3. And so there's your antiderivative. And if I want to evaluate that from 0 to 3/4, there's what I get, 9 pi over 256. Now, I will say that if we stopped right here and replaced the limits of integration with the 0 and pi over 2, you might get something that looks like this. And wow, that's a lot less work, isn't it? Okay. And here's some confirmation. Here's f of x. Here's big F of x, the antiderivative. And if I take the derivative of that, I get the same graph. So that kind of confirms what's going on here. Desmos evaluated the integral. F of 3/4, which is the antiderivative, gives us the same result. And there's 9 pi over 256, same result. So it looks like we got it right. But there's a little caveat. Here's the function. And f of 3/4 is undefined. So this is actually a problem, because we actually have to use this idea right here, technically, to say that this, since we've got an infinite integrand at 3/4, because we're dividing by 0, we have to do this. And so that this integral is equal to the limit as t approaches 3/4 from the left of the definite integral from 0 to t of f of x dx. And so if we replace this with what we got on the first board and evaluate from 0 to t and take the limit as t approaches 3/4 from the left, we get the same result. Okay, but technically this is what you have to go through. And of course the inverse sine of 1 is pi over 2, so 9/128 times pi over 2 gives us 9 pi over 256. Okay, there you go. Hope that helped. If you have any questions, post a comment.